Hello everyone, today we are going to talk about the production of biogas from kitchen waste. Here is our group list. Kitchen waste can be classified into two types, biodegradable and non-biodegradable. For example, spoiled vegetables, fruit skin, cooked meat, uncooked meat, bones, eggshells, and used tea bags are biodegradable kitchen waste. Wrath, coffee grounds, tissue paper, plastic package, glass, and metal container are non-biodegradable kitchen waste. From EPD, 44% of perishable waste is sent to landfill, mainly is food waste. Also, about 3,600 tons of food waste is generated every day in Hong Kong. It is a large amount of fuels and energy source. For example, Old Park is the first organic resource recovery center in Hong Kong. Anaerobic digestion technology is utilized to obtain methane from food waste. Old Park handles 200 tons of food waste per day and generates about 14 million kilowatt-hours of electricity, which is equal to the electricity consumptions of 3,000 households. So, if 3,600 tons of food waste is traded, 252 million kilowatt-hours of electricity can be generated per day. The electricity generated is equivalent to power consumption by about 54,000 households. It is a considerable energy source. There are 4 benefits of using biogas. First, reducing waste sent to landfills. Second, mitigating stress of landfill saturation. Third, reducing fossil fuel usage. Finally, completely utilizing potential energy from waste.
Anaerobic digestion is a cleaner and more efficient alternative to aerobic composting, as anaerobic digestion is generally an energy-producing process, while composting is mostly energy-consuming. In addition, methane produced from composting is released into the environment, where methane produced in aerobic digester is used as fuel. In terms of methane production, anaerobic digestion has higher control over the methane production and contributed to lower the carbon footprint of the kitchen waste management in the way of fugitive emissions are lower than the emission in the case of landfill and aerobic digestion. 95% of the biodegradable kitchen waste can be used for anaerobic digestion. The process of turning kitchen waste into energy is shown in the following. After the kitchen waste is collected, it goes to hopper. The kitchen waste pre-treatment facility will adopt mechanical treatment for impurity removal and size reduction. In the impurity separator, the pre-treated kitchen waste is separated out. It then fed into the anaerobic digestion tank. In the anaerobic digestion, there are 2 main products. Firstly, the methane generated in the process is captured and used for power generation and fuel supply. Another useful product is the digest sink to the bottom of the tank. After dewatering, it will send to the teapot for further energy recovery.
In anaerobic digestion, the bacteria break down the organic matter in kitchen waste without the presence of oxygen, and methane and carbon dioxide with very small amount of water vapor and other gases are produced. This is the flowchart of anaerobic digestion. There are 3 major stages, including hydrolysis, acid forming, and methanogenesis. At the end, biogas can be produced. During hydrolysis, complex organic molecules are broken down into simple soluble monomers. Soluble sugars, amino acids, glycerol, and long-chain carboxylic acids can be the end products. For example, C6H10O4 in kitchen waste is converted into glucose and hydrogen. Acid forming includes fermentation and acetogenesis. For fermentation, soluble organic products from hydrolysis are converted into simple organic compounds. Volatile fatty acids, ketones, and alcohols can be the products. For acetogenesis, soluble organic products from hydrolysis are converted into simple organic acids. Acetate, carbon dioxide, and hydrogen can be the end products. The last stage is methanogenesis. Biogas is produced from acetic acid and fermentation of alcohol. The end products are methane, carbon dioxide, and water vapor. There are 5 major factors that affect the overall performance and the yield of biogas production. The first one is the pH value of reacting material. Second, the composition of kitchen waste. Third, organic loading rate. Fourth, the retention time in anaerobic digestion reactors. Fifth, the operation temperature.
Anaerobic digestion is not a perfect method to handle the kitchen waste. It's facing some challenge at the same time. The first one is the safety challenge. In the process of anaerobic digestion, it requires some harmful bacteria for the digestion, like E. coli, Salmonella. If the plants do not have safe handling process of the kitchen waste, the harmful bacteria will leak from the container and bring the damage to the environment and the human health. The second challenge is the technology challenge, as anaerobic digestion is a dangerous and technology-intensive process. For the developing countries, the high technology requirement may be a difficulties for them. The final challenge will be the social challenge, since the process of anaerobic digestion will produce odor and noise. The neighbor life quality may be affected by those factors. Next, let's talk about a real case of kitchen waste to energy in Hong Kong, Old Park 1. It located at North Lantau and collects kitchen waste from the restaurant. The kitchen waste will be used to produce biogas and finally transferred to electricity. Since it is a trial point for waste to energy, it can only handle 200 tons of waste per day, which is a small number compared to the total kitchen waste we generate per day. To have a larger scale of application of anaerobic digestion in Hong Kong, we will have some suggestions. First, attract more restaurants to provide kitchen waste through the policy, like tax reduction or gift certificates to the restaurant. Second, try to set up the kitchen waste collection points in more estates. Therefore, more raw material can be provided for the digestion. Third, the government can find more possible location for the plant. The location should be far from the residents and bring less impact to them. This is the end of our presentation.